We'll be looking at indices, and since it is a revision class, we'll be going into solving a question right away. This question are taken from General Mathematics, New General Mathematics SS3, the revision part which follows the WAEC syllabus. So the laws of indices, we have 7 laws of indices. The first law is the law of addition, which says a to the power or s to the power of a, as it is here, multiplied by s to the power of b is s to the power of a plus b. That is the law of addition. Then the next law is x to the power of a divided by s to the power of b, which is s to the power of a minus b. The other law, the third one, s to the power of 0. Any number to the power of 0 is 1. Then the negative indices, x to the power of negative a is 1 over x to the power of a. And you have the product as x to the power of a to the power of b is x to the power of a times b, which is s to the power of ab. We also have the fractional index, x to the power of 1 over a is the 8th root of x. The last law, x to the power, permit me to use n here instead of what we have here, a over b. So x to the power of m over n, for example, is the nth root of x to the power of m. We're going to use these laws to solve problem. The first one here says simplify 25 to the power of 1 over 2. So 25 to the power of 1 over 2. I'm going to apply the law that says x to the power of 1 over n is the nth root of x. So the nth root of x here, since this is 2, we don't need to write the 2. So any number to the power of half is the square root of that number, and square root of 25 is 5. Another way we can solve this is to express 25 in index form. So 25 to the power of half, we can write that as 5 to the power of 2, then to the power of half. These two will cancel out when we apply the law that says s to the power of a to the power of b, which is s to the power of a times b. So when we multiply 2 by half, of course, is 1. So 5 to the power of 1 is 5. That is that for question 1. For question b, we have 9 to the power of 1 over 6 multiplied by 9 to the power of 1 over 3. If we apply the first law, this will be 9 to the power of 1 over 6 plus 1 over 3. And 1 over 6 plus 1 over 3, let's solve the fraction here. 1 over 6 plus 1 over 3. The LCM of 6 and 3 is 6. 6 divided by 6 is 2. 6 divided by 6 is 1. 1 times 1 is 1. 6 divided by 3 is 2. 1 times 2 is 2. So 1 plus 2 over 6. Have 9 to the power of 1 plus 2 is 3. We have 3 over 6. 3 here 1. 3 here 2. So this is 9 to the power of 1 over 2. And any number to the power of 1 over 2 is the square root of that number. So square root of 9. Square root of 9 is 3. In question C, we have 4 to the power of 3 divided by 4 to the power of 5. This will be 4 to the power of 3 minus 5, which is 4 to the power of minus 2. Now applying the law that says a to the power of negative n is 1 over a to the power of n. If I apply the law, then that will be 1 over 4 to the power of 2, which is 1 over 4 to the power of 2 is 4 times 4 is 16. And for question D, I have 2 to the power of 6 divided by 2 to the power of negative 6. That will be 2 to the power of 6 minus 6, which is 2 to the power of 6 minus times minus is plus 2 to the power of 12. And question E, we have 2 to the power of 3 to the power of negative 2. Apply the law that says a to the power of n to the power of m is a to the power of n times m. So this will be 2 to the power of 3 times negative 2, which is 2 to the power of negative 6. And if we apply the law that says a to the power of negative n is 1 over a to the power of n, this will be 1 over 2 to the power of 6, and 2 to the power of 6 is 64, so 1 over 64. And question F, we have 27 to the power of negative 2 over 3. Let's remove this negative index first. This will be 1, that is, if I apply the law that says a to the power of negative n is 1 over a to the power of n. If I apply the law here, that will be 1 over 27 to the power of 2 over 3, which is 1 over this 2 over 3. Because of the 3, we take the cube root of 27, then to the power of this 2 here. That is, I'm applying the law that says a to the power of n over n is equal to the nth root of a, then to the power of m. So doing that here, we have the cube root of 27 is 3. I have 1 over 3 square, which is 1 over 9. And question G, we have 81 over 16 to the power of negative 3 over 4. This will be removing these negative indices. We have 1 over 81 over 16 and to the power of 3 over 4, which means I have 1 over the 4th root of 81 over 16. Why 4th root? I'm applying the law that says a to the power of n over n is equal to the nth root of a to the power of m. So in this case, 4 corresponds to n. Look at it there, 4, 4. Why 3 corresponds to m? So we follow this law to have nth root of a to the power of m. That is 4th root of 81 over 16 to the power of 3. And 4th root of 81, that is a number that multiplies itself 4 times to give 81, which is 3. Let me write this one up here first. So this gives us 1 over 3. Then 4th root of 16 is a number that multiplies itself 4 times rather, to give 16, which is 2. Then to the power of this 3 here, I have 1 over 3 to the power of 3 is 27, and 2 to the power of 3 is 8. This is 8 over 27. That is this 1 divided by this. Is like saying 1 divided by 27 over 8. And when we divide by fraction, the sign of division will change to multiplication. Then we multiply by the reciprocal of the second fraction. That is why we have this. Example 2, it says simplify 9s to the power of negative 3 multiply by 25, no, 2s to the power 5 rather. First of all, we need to multiply the numbers. 9 times 2, then s to the power of negative 3 times s to the power of 4. 9 times 2 is 18, s to the power of negative 3 plus 5, which is 18, s to negative 3 plus 5 is 2, so 18s squared. Then for the b, have 2d to the power of 3 to the power of 2. These two outside here affect both 2 and d to the power of 3. So this will be d, a bit 2 rather, to the power of 1 multiplied by these 2 here. Then multiply by d to the power of 3 multiplied by 2. Applying the law that say a to the power of m to the power of n is a to the power of m times n. So 2 to the power of 2 multiplied by d to the power of 6. 2 to the power of 2 is 4. So I have 4d to the power of 6. Now question C, 2a to the power of 3 divided by a to the power of 4. That will be 2a to the power of 3 minus 4, which is 2a to the power of minus 1. And this we can write as 2 times 1 over a. Why 1 over a? A to the power of negative n is 1 over a to the power of n. So a to the power of negative 1 will be 1 over a. Then 2 times 1 is 2, then all over a. Finally, question D, 32n rather, 32n to the power of 1 over 5 is 32 to the power of 1 times 1 over 5, since this 1 over 5 affects all the number inside, multiply by n to the power of 1 times 1 over 5, (1 over 5), which is 32 1 over 5 n 1 over 5. Now 32 to the power of 1 over 5 is the fifth root of 32, which is 2. Or another way we can write that is to express 32 in inverse form, which is 2 to the power of 5, then to the power of 1 over 5, this 1 over 5, right? Then n to the power of 1 over 5. So this 5 can cancel this 5, which is 2 times n to the power of 1 over 5. That is 2n 1 over 5. And question be the last set of questions. So we should solve the equation x to the power of 1 over 2 equal to 3. And to solve question like this, I'll try to get rid of this half here by multiplying both powers by 2. So I have x to the power of 1 over 2 times 2 is equal to 3 to the power of 1 times 2. So these two can cancel out. S equal to 3 to the power of 2, which is 9. And the b part, s to the power of 1 over 3 equal to 2. Again, to clear this 1 over 3, I'll multiply both powers by 3, equal to 2 to the power of 1 times 3. So 3 can cancel 3, s equal to 2 to the power of 3, which is 8. And the c part, s to the power of negative 2 is equal to 16. This implies, again, to clear this, I need to express this in index form, or let's express this in positive indices first, which is s to the power of 2 equal to 16. And when we cross multiply this, 16x squared is equal to 1, s squared therefore is equal to 1 over 16, which implies s is square root of 1 over 16. And square root of 1 over 16 is 1 over 4. And question D, have 3s to the power of 3 equal to 24. Let's divide both sides by 3. S to the power of 3 equal to 8. Expressing 8 in index form, 8 is the same thing as 2 to the power of 3. Now these are exponential equations, and when the bases are the same, we equate the powers. On the other hand, if the powers are the same, like in this case, we equate the bases. So we have to the power of 3 on both sides. That means s is equal to 2. Finally, second to the last, s to the power of negative 2 over 3 is equal to 9. Let me start by clearing or writing this in index form in positive indices. 1 over x to the power of 2 over 3 is equal to 9. That means 9s to the power of 2 over 3 equal to 1. S to the power of 2 over 3 equal to 1 over 9. Now to clear this 2 over 3 here, let me multiply both sides by 3. So s to the power of 2 over 3 multiplied by 3 equal to 1 over 9 multiplied by 3. So this will cancel this. S squared equal to 1 over 9 to the power of 3. S squared is equal to 1 to the power of 3 is 1. 9 to the power of 3 is 729. S will be square root of 1 over 729. Square root of 1 is 1. Square root of 729 is 27. Therefore, S is equal to 1 over 27. And for the last question, 5x equal to 80 s to the power of negative 1 over 3. Let me start by dividing both sides by 5. So this 5 will be gone. S will be 80 divided by 5 is 16 to the power of 1 over 3. Expressing this negative index here as a positive index, I will have 16 over s to the power of 1 over 3. If I cross multiply this, is over 1, I have s times s to the power of 1 over 3 equal to 16, meaning s to the power of 1 plus 1 over 3 equal to 16. 1 plus 1 over 3, that is s to the power of 3 plus 1 over 3, which is 16. S to the power of 4 over 3 equal to 16. Now to get rid of this 3, 4 over 3, let me multiply both sides by 3 equal to 16 to the power of times 3. So this 3 will go. S to the power of 4 is equal to 16 to the power of 3. 16 to the power of 3 is 4096. Of 4096. S will be 4th root of 4096. The fourth root of 4096, which number multiplies itself 4 times to give us 4096? So s equal to 8. 8 times 8 times 8 in 4 places is 4096. We have to simplify 4 over 25 to the power of negative half multiplied by 2 times, multiplied by 2 to the power of 4 divided by 15 over 2 to the power of negative 2. If I have 4 over 25 to the power of negative half multiplied by 2 to the power of 4 divided by 15 over 2 to the power of negative 2. This will be, because of this negative index here, this will be 25 over 4 to the power of half, then multiply by 2 to the power of 4, divided by, again there's a negative index here, so I'll have 2 over 15 to the power of 2, which is, anything to the power of half is the square root of that thing. Square root of 25 is 5, square root of 4 is 2, multiplied by 2 to the power of 4 is 16, divided by 2 to the power of 2 is 4, and 15 to the power of 2 is 225. So we'll have 5 over 2 times 16 times, when dividing by fraction, the sign of division will change, and then multiply by the reciprocal of this fraction. 4 here 1, 4 here, 2 here 1, 2 here 2. So I have 5 times 2, which is 10. 10 times 225 is 2250. And the last question, 56 x to the power of negative 4 divided by 14x to the power of 8. That will be 56 divided by 14 times s to the power of negative 4 minus 8. Now 56 divided by 14 is 4. So this is 4x to the power of negative 4, minus times minus is plus, which is 4x to the power of negative 4 plus 8 is 4,